Hey, this is Larry the Cable Guy. You are watching NASA TV. Get her done. Boy, it's my favorite channel. Seriously.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I am ready for the event.
European Space Agency, this is Mission Control Houston. Please call station for a voice check. European Space Agency, this is Mission Control Houston. Please call station for a voice check.
Station, this is ESA PAO from ASI headquarters in Rome. How do you hear me?
And hello, ESA PAO. Hello, everybody at ASI headquarters. Welcome aboard. I have you loud and clear.
And hello, ESA PAO. Hello, everybody at ASI headquarters. Welcome aboard. I have you loud and clear.
Samantha, ti lascio ora la parola a Delfina Bertolotto.
To Cristina Bertolotto. Thank you.
Ciao, Samantha.
Hi, Samantha.
Sono Delfina Bertolotto.
I'm Cristina Bertolotto. I'm in the auditorium of the Italian Space Agency, and we're celebrating, as you know, the event of closing the national event 2014-2015 Italy Mission X. We have 260 students and 40 teachers coming from Rome schools, Montecongrati, Matera, Ercolano, and Bisceglie. We have a big participation of participants, students, who have been training according to the program for 2 months and would like to ask you some questions. But first of all, there is something definitely important that we have to talk about. Tell me if you heard this thing.
Mi è arrivato tanto calore.
All I got is a lot of warmth, affection, and enthusiasm, but I don't believe I understood the words. Happy birthday, Sam.
Immaginavo,
I figured. Thank you. Thank you very much. Best wishes. Okay, so there's only one question I want to ask you. I will take just a little bit of time because I want the students to take more time. We have heard you last week talk about our Minister of Research, and you were giving counsel on how students from school age should follow beyond training as astronauts, what they should do to realize their dreams, as you did, Samantha. Can you tell them also? Of course, Delfina. So first of all, hello everyone, and congratulations for completing Mission X. What I like to say when I talk about, or when I encounter young people like you, is that even since your age, you have to find opportunities to grow and become strong. So as you've been training and your muscles with Mission X, it's important to find opportunities to train character and force of character. So a little bit to complicate your life and find challenges that maybe you're not sure that you have the strength to face, because only by facing these challenges is how you find that faith in yourself. But talking about Mission X, I want to tell you something more. Even when you have a lot of character and determination, sometimes it's not enough. So it helps if some things that are important to you and for your health and it's important when things like that have become habits that you don't even have to think about. So I hope that with Mission X, you have started a path to acquire habits that are healthy for nutrition and health, so that growing up, these are things that are in your pocket. You don't have to think about it. You don't have to make any efforts. They're habits. And now you can concentrate on your grit and determination. You can use those things on more important things that can allow you to achieve your dreams. Thank you, Samantha. And now I will give the word to the first girl who is going to ask you a question. Hi, I'm Viola. I come from Belly School, and this is the question we have made. Considering that you're in space now since over 4 months, and Earth you will only see from a window, what do you miss the most from the blue planet? And are you able to stay on track with what's going on Earth?
Ciao, Viola.
Hi, Viola. We are hyper-connected up here, I have to say. We have internet access, even though it's a little limited. But they send us news and newscasts if we want to watch them. Usually the ones from the day before, so we're always a little bit late. And of course we can talk to our loved ones, families, via telephone or email. So let's say that we don't miss contact with what's going on Earth. Of course, you don't have the physical presence, the smells, the taste, and the immediate presence of your loved ones and your family. So these are the things that you miss a little bit. But I have to say, I love life up here, so I tend to not dwell so much on these things. I'm Giulia. I come from Giovanni Verga School of Rome, and here's the question. So we have studied that you astronauts, to stay healthy, you have to train regularly. How much physical exercise do you do per day, and what instruments do you use to train?
Ciao, Giulia.
Hi, Giulia. So, our activity program has 2.5 hours dedicated to sport, to physical activity, and they're divided in two kinds. One is resistive exercise, so that's what on Earth you do with weights. So here we're weightless, so of course working with weights would not work, so we have a machine called ARED, which allows you to do the same types of exercises that you would do in the gym, just without weights. And this is to maintain muscular tone, but also to give stimulus to our bones so that our body does not decide to lose bone mass while we're here without weight. And then we have a platform, a treadmill, somewhat of a bike, so without a seat. Even the treadmill, we have a harness with some belts that will that keep us attached to the treadmill so that we're able to run even without weight. Hi, I'm Giuseppe. That each astronaut can bring with them. Hi, I'm Giuseppe. I'm from Sant'Arcisio School, and this is the question we've made. I've read that each astronaut can bring with them up to 1.5 kilo of personal effects. What did you bring with you?
Ciao Giuseppe.
Hi, Giuseppe.
Dunque,
So, I brought, for the most part, in this 1.5 kilo that you're talking about, it is what we can bring with us with the Soyuz. So it's what flies with us and comes back with us. So I put the most precious, beloved things with me. For the most part, it's small objects that friends and family have given to me that are objects of significance for them, so that I brought here to add even a little more significance that I will then return to them. And then I brought with me some few hundreds of little books that you can keep in the palm of your hand, which I've used to collect some poems and little excerpts that are of significance for me, up to 1.5 kilo of, in the words of writers and poets, they give somewhat of a meaning of living in space, and those two will be gifts for when I come back.
Ciao Samantha.
Hi Samantha, I'm Emanuele.
Sono Emanuele da Matera.
From Matera, the European Capital of Culture for 2019 from Giovanni Pascoli Institute. In what moment did you feel that your passion for space started? Was there a teacher that motivated you in this direction?
ciao Emanuele.
Hi Emanuele, and congratulations to Matera. So I've always dreamed since I was little to go to space, even before I understood how you go into space and what's an astronaut was in reality. So I used to watch sci-fi movies, and I was dreaming of exploring space and flying on a spaceship. But then growing up, I became more enamored with science and technologies and flight, so I became an engineer and then a military pilot. So all these things that put me on this path. So the world of astronauts is a world of technology, science, and flight. And it's also a very international, intercultural environment. So my other passion is languages. So it's a type of life that's very much made for me, and I'm very happy in it because all my passions converge in it.
Ciao Samantha.
Hi Samantha, I'm Matteo from the Comprehensive Institute Visconti of Rome, and this is a question that I wanted to ask you. So throughout your path to become an astronaut, did you find any obstacles? And when they seemed like they were unsurmountable, did you think about giving up? And if not, how did you find solutions to your problems?
Ciao Matteo.
Hi Matteo.
È una domanda interessante.
It's an interesting question. I don't think I've ever had any obstacles that seemed unsurmountable, but also perhaps because mentally I've never accepted that an obstacle would be unsurmountable. There might be difficulties. It can require, facing an obstacle can require sacrifice and effort, but let's say that in my head nothing was ever unsurmountable. So, and almost always it's like that. I really believe, especially when you're very young like you, that you can face life and difficulties with faith in yourself, that a solution with effort and a little bit of effort you can find. So don't ever think about giving up, because this way you'll never achieve important objectives.
Ciao.
Hi.
Ciao Samantha, io sono
Hi Samantha, I'm Giulia.
vengo da
I come from Montecompatri.
vorrei chiedere
I would like to ask you a question.
che dice cosa mangerai il giorno dopo
What
che
will you
sarai
eat the
tornata
day
dallo
after you
spazio?
come back from space?
Ciao Giulia.
Hi Giulia.
Beh, difficile
Well,
prevedere che
so
cosa
it's hard to
però
predict what I will want, but I believe that I will eat a big salad, one of those big salads that you eat in the summer, full of of fresh vegetables, hopefully some seeds and nuts, a little bit of mozzarella and tomatoes. So this is a little bit what I imagine that I will eat the day after I return.
Ciao, sono Francesca.
Hi, I'm Francesca from the Comprehensive Institute Minazzi of Matera. So here's a question. Here on Earth, we take everything for granted. We're used to having everything and everyone that we need right here. When you're far away from everything and everyone, do you feel that you're able to appreciate more the value of every single thing?
Ciao Francesca.
Hi, Francesca. Well, so a little bit you understand that a lot of things and a lot of commodities that you have on Earth that you believe are essential, important, that you can't live without, then in the end, they're not so important after all. You adapt to living very easily and living in a more Spartan way with less amenities. So it's just a question of adapting and of being a little more flexible. And you live really with serenity, without a lot of things. So I say when you're here, it's like camping. You have to adapt, but it's kind of a luxury camping because at your disposal, we don't have running water, but we have a toilet. We have a great variety of foods and beverages. We have a little bit of room to sleep.
Ciao, sono Enrico dalla scuola media Monterisi di Piceglie e vorrei chiederle se a bordo della stazione spaziale vi siete presi...
Hi, I would like to ask you if on board of the International Space Station you got the flu like we did at school and how you cured yourself. So the virus, can the virus spread in situations of microgravity? Hi, Enrico. The question is interesting. So the answer is no. We did not get the flu because the flu virus is not here on board. We're very careful every time that a new vehicle arrives. We're careful that people don't bring something like the flu or even another microbiological cargo. So we test the air, surfaces, and water. We continuously test to make sure that there's no contamination. But your question is interesting in another way. It's true that we've made experiments with pathogens, also viruses, and we've verified that in weightlessness they're much more virulent and aggressive. And this is it goes hand in hand with an immune depression. So our immune system of animals and human beings, it's compromised up here. So it's surely thinking about future missions and exploration. It's something that we need to study and go into in depth because we have stronger pathogens and a weaker immune system, which is not a very happy combination.
Ciao Samantha, sono Giada dell'Istituto...
Hi Samantha, I'm Giada from the Comprehensive Institute Al Samurante. I wanted to ask you if throughout all these months on board the space station you missed your family.
Ciao Giada.
Hi Giada. As I've talked about earlier, there are lots of possibilities to stay in contact. So perhaps what I didn't say earlier is that once a week they organize a video conference where we can see our family and our family can see us. And for 1 hour we can talk this way. So the opportunities to contact we have, and there are many. And in many ways you get used to allow these moments of communication to become very special and intense. Of course, you're missing the contact and physical presence and the possibility to hug and be close. So this, of course, a little bit we miss.
Ciao Samantha.
Hi Samantha, I'm Davide from the Comprehensive Institute Volterra di Riccia, and I would like to ask you about what you do during your rest periods.
Ciao Davide.
Hi Davide. So we don't have a lot of free time, especially during the week. I have to say the days are very full, and you get to evening and you eat, and perhaps you call the family, you write a couple of emails, and at least I'm tired, so I sleep like a stone afterwards. But you have a little more free time in the weekends, unless they're the weekends like we've had recently. But I like to take photographs, so we have this very beautiful view from Earth, from the cupola, and I've tried throughout the mission to take photos of places that struck me so that I can share it with people on Earth that have been following the mission. But of course, otherwise, we spend time together. Usually on weekends, we organize dinners where we, all 6 of us, dine together. This past weekend, of course, we celebrated my birthday. And I have to say, almost the entire crew has had birthday during the mission. So celebrating weekends is sort of a tradition that has been happening often.
Ciao Samantha.
Hi Samantha. This is Flavio from the Comprehensive Institute of Rome. I would like to know how you recycle the useful substances and how you get rid of waste.
Ciao Flavio.
Hi Flavio. It's a very interesting question. We have a life support system here, which is a closed loop system, meaning that we recycle all the waste products of human life, of course, except for solid waste. So urine is recycled and transformed into potable water, but even sweat and humidity that is injected into the cabin is recondensed into the air conditioning system, and then it's sent to a system that recycles it and transforms it into potable water. So the water recycling system is closed loop, except for some leaks that are happening, which that's why we replenish. But even breathing, the carbon dioxide that we breathe is removed from the cabin. Otherwise, this is very important. Otherwise, this would be toxic because we don't have plants up here. We have hardware that removes carbon dioxide from the atmosphere, and even then it's a completely closed system. So we have a Sabatier cycle that closes the cycle, and then I forgot to tell you, the oxygen is produced by electrolysis with water.
Ciao Samantha.
Hi Samantha. This is the end of this link. We thank you so much for being with us today. All the Mission X boys and girls wish you a happy birthday.
Grazie.
Thank you. Thank you, Delfina. Thank you to all the boys and girls of Mission X, and a greeting from Paxi. Bye.
Thank you, everybody. Thank you. Thank you so much. So today I'd like to talk about the next chapter in this story. We will increase Earth-based observation, and we will extend the life of the International Space Station. We will build on the good work already done on the Orion crew capsule. We will increase investment right away in other groundbreaking technologies. We want to leap into the future by investing in groundbreaking research and innovative companies. We're going to modernize the Kennedy Space Center, creating jobs as we upgrade launch facilities. We will partner with industry. We will invest in cutting-edge research and technology. The space program has fueled jobs and entire industries. And in fulfilling this task, we will not only extend humanity's reach in space, we will strengthen America's leadership here on Earth.
good morning once again from the International Space Station Flight Control Room at the Johnson Space Center in Houston, where at this hour, flight controllers here at the Johnson Space Center, as well as half a world away at the Russian Mission Control Center in Korolyov outside of Moscow, are continuing to work to assess the overall condition of the ISS Progress 59 cargo ship, the unpiloted Russian resupply craft that launched just under 3 hours ago from the Baikonur Cosmodrome in Kazakhstan. That launch occurred on time at 2:09 and 50 seconds a.m. Central Time, which was 1:09 and 50 seconds p.m. at the Cosmodrome in Kazakhstan off of Site 31 and the launch pad at that remote Central Asian launch complex. You see the replay of the launch with the main engine start. The engines came up to full speed. The hold-down arms were retracted, and the three-stage Soyuz booster and Progress 59 began their journey to the International Space Station. This was intended to be a single transit for the Progress 59 cargo ship. Again, you're watching a replay of its launch that occurred just under 3 hours ago. However, at the point at which the spacecraft separated from the third stage of the Soyuz booster, 8 minutes and 45 seconds after launch, telemetry issues cropped up where Russian flight controllers were unable to receive confirmation on the ground in Korolyov that the navigational antennas and the repressurization of the fuel manifolds in the propulsion system of the Progress had both activated and had deployed as planned to enable the Progress to begin its journey to the International Space Station. So as a result, shortly after the Progress arrived on orbit, the Russian flight control team determined to default from a 4-orbit 6-hour rendezvous because of these systems issues with the telemetry system, and deferred to a backup 34-orbit 2-day rendezvous plan, which is always kept in the hip pocket of the Russian flight control team in the event of systems issues that could crop up early in the rendezvous process for either a Progress resupply vehicle or a manned Soyuz spacecraft. About an hour and a half ago, over Russian ground stations, attempts were made to send commands once again to receive telemetry from the onboard systems on the Progress 59 to determine the overall health status of the Progress's systems, but there was no joy in receiving that telemetry on the ground, and so we are standing by for the next pass over Russian ground stations that is scheduled about 8.5 minutes from now, at which time Russian flight controllers in Korolyov will again send commands to the Progress 59 to try to receive telemetry that will either confirm or not the overall health of both the navigational antenna system as well as the propulsion system, and whether or not those manifolds repressurized, which is key to enabling the Progress to conduct its burns to reach the International Space Station. The earliest Progress can dock to the International Space Station now would be Thursday morning, and a docking around 4:03 a.m. Central Time. But again, this is highly dependent on the overall systems of the Progress 59 and whether or not it can receive commanding from the Russian flight controllers in Korolyov and how it responds to that commanding. The International Space Station of this hour is flying from southwest to northeast at an altitude of 257 statute miles over the northwest portion of Africa on an orbit that will carry it over Morocco, the northern coast of Africa, and over central Italy a short time from now. On board the International Space Station, NASA flight engineer Scott Kelly has been working throughout the course of the last couple of hours on the replacement of a distillation unit for the urine processing assembly aboard the International Space Station. That work is just about complete, and the mechanical systems officer here in Mission Control reports that they have a healthy urine processing assembly system. As work continues on board the International Space Station, the crew was informed several hours ago that there would be no docking of the Progress 59 to the space station later this morning. Again, that docking has been postponed to no earlier than Thursday, and we'll see as time goes on whether or not systems status on the Progress 59 cargo craft, which is carrying over 3 tons of food, fuel, and supplies for the Expedition 43 crew, whether or not the Progress can make it to the space station as early as Thursday. So we'll be standing by here as the Progress passes over Russian ground stations a few minutes from now, and we'll be monitoring the Russian flight control loops to determine whether or not there has been any success in sending commands to the Progress, and in turn, whether the Progress is processing telemetry through its onboard computers back to the Russian flight control team in Korolyov.
How are you? This is Anton. Can I speak to Nikolai, please? Yes, of course. Nikolai, before you fly away somewhere, we have electron low pressure message that popped up at 906. Am I going to clear that message and the rest of the messages in the log? Yeah, because that was about the time when the electron activation was taking place. That's why. Anton, give us a couple of minutes. We're going to look at our telemetry and then get right back to you. And by the way, speaking of telemetry, do you know if that was restored on the Progress? They're going to have to do some kind of restart because they have not been able to recover telemetry flow now. So as soon as I've got something of substance, I will let you know with respect to Progress.
МКС по Москве, ВСГ-1 для Антона по поводу сообщений управляющего в лэптопе.
Station Moscow Space Program 1 for Anton and the error messages on the central post computer.
This is Mission Control Houston, just minutes away from the Progress 59 cargo craft passing within range of Russian ground stations on the second of its daily orbits. There are several more orbits of Russian ground station telemetry processing capability before the Russian ground station capability expires for the day. So we'll be standing by to receive any word on further telemetry or commanding capability to the Progress 59 and what the overall status of its systems may be.
Station Moscow, Space Program 1. About the messages on the laptop? Yes, Nikolai. Anton, you are going to clear the whole message log? It was all due to electron activation. So
you heard just a moment or two ago Russian flight controllers telling Anton Shkaplerov, the Russian cosmonaut, one of 3 on board the International Space Station, that they have no further news on the telemetry and commanding status of the Progress 59 cargo craft, that there may be a plan required to restart the onboard computer on Progress in an effort to coax it back into a nominal telemetry processing capability. But again, all this information is very preliminary, and without a hard set of data and telemetry from Progress, The Russian flight control team continues to explore troubleshooting options, the next series of which will be the result of what we learn as the Progress passes over Russian ground stations, with that pass expected to begin here shortly. This is Mission Control Houston, once again waiting for further information from the Russian flight control team in Korolyov. You're looking at a view of their flight control room from a balcony camera. Very large flight control room there in their control center outside of Moscow. 59 Progress should be within range of Russian ground stations, or shortly will be acquiring within Russian ground station coverage, at which point the Russian flight control team will continue its efforts to establish a stream of telemetry to the 59 Progress cargo craft. This is Mission Control Houston. At this point, Russian flight controllers are indicating no telemetry being received from the Progress 59 cargo craft as it passes over a succession of Russian ground stations. So we'll be standing by for further information as this pass continues.
Houston on 2 for TOCA.
Go ahead on 2.
Hey, Jeanette, I am going to reclaim the water from the used wastewater bag, and I was wondering while I do that, could you take care of steps 1 and 2 of the TOCA analysis procedure?
Okay, copy that, Sam, and those steps are already complete.
Awesome, thank you.
Once again, Progress 59 launched 3 hours and 10 minutes ago from the Baikonur Cosmodrome in Kazakhstan, passing over Russian ground stations, Russian flight controllers attempting to acquire telemetry from the spacecraft and to assess the current status of the navigational antennas and the propulsion system on the spacecraft. It has been this telemetry issue with Progress 59 since it arrived in its preliminary orbit. That resulted in a default in the rendezvous scheme from an approach and docking to the International Space Station later this morning to a 34 orbit 2-day docking rendezvous profile that, if the Progress's systems can support, would result in a docking to the Pirs docking compartment on Thursday morning. This is Mission Control Houston. The pass over Russian ground stations is now complete on the second orbit for the Progress 59 cargo craft. And as was the case about an hour and a half ago on the first of its completed orbits of the Earth, no credible telemetry was received on the ground by the Russian flight control team that could confirm either the deployment of navigational antennas or the repressurization of the propulsion manifolds in the propulsion system of the Progress 59 cargo craft. So that would appear to indicate no change in the uncertain status of the Progress 59 systems. We are continuing, however, to monitor for any additional information.
Отвечаю, Антон Возгредин.
Moscow Station, Space Program 1. Go ahead. I'm done with the experiment. There's a folder on OCA. I named it after the radiogram number. 7782, and it's zipped and ready to grab. And Tom, which activity was it? You were a little choppy there at first.
Ну, у меня эксперимент.
Viru experiment. I'm sorry, virtual experiment. All right, copy. It's 319.
Хорошо.
Copy all. Thank you. Nikolai, there was a cheapest radiogram that I was promised to receive today. Anton, I know for a fact that the hard copy was making rounds here in MCC, getting all the signatures and the approval cycles and everything, so it should be on its way to you. Okay, copy.
This is Mission Control Houston. Once again, the latest pass by the Progress 59 cargo craft over Russian ground stations did not produce any meaningful telemetry received on the ground there at the Russian Mission Control Center. Or the ability of the Russians to place commanding on board the spacecraft. So no change in status for the Progress 59 cargo craft that launched almost 3.5 hours ago from the Baikonur Cosmodrome in Kazakhstan. We're standing by for any additional information in the wake of this pass over Russian ground stations.
Москва, ответим МКС канале СГ-1.
Moscow Station Space Tower 1 for UDOD.
Да, слушаем.
Go ahead.
Значит, я прошел пункт 7.
I'm done with step 7. I'm done with step 7.7.
Заполнил анкету после первого.
I completed the form after stage 1.
Вот. Потом я отошел.
And then I stepped away because I needed to. And I shut down the BKFS. For 2 minutes, then I reconnected when I was back.
Перед следующим этапом.
Before the next stage. And it got me going into a calibration all over again. How do I get into 7.8 quicker? Unfortunately, you'll have to redo all the steps because activation of the BKFS means that it didn't save any data and it completely disconnected, so you need to redo it. That's not good. You shouldn't have shut it down ever.
Ладно, пошел по новому. Но это надо.
Okay, I'll do it again.
Выделить как-то.
It should have been highlighted in red or something.
Предупреждение, что его нельзя отключать. Я думал, первый этап.
Хорошо, мы учтем это.
Okay, we'll take that into consideration.
Ну, 3 часа же эксперимент идет.
Yeah, because it's a 3-hour experiment. You know, we're human beings. I needed to step away.
А я подвязан к
Ну,
нему.
к сожалению, да. Если у вас есть возможность.
Yeah. Unfortunately, yes. If at all possible.
This is Mission Control Houston. Here in the International Space Station Flight Control Room, the visiting vehicle officer, Heidi Paris, has passed on to Flight Director Jeff Radigan that the latest ground station pass by the unpiloted ISS Progress 59 cargo ship yielded no joy in either the ability of the Russian flight controllers to send commands to the spacecraft or the resulting receipt of telemetry on the ground. To recap, the Progress launched on time some 3.5 hours ago at 2:09 a.m. Central Time, 1:09 p.m. Baikonur time from the Baikonur Cosmodrome in Kazakhstan. The Progress had a nominal ascent to its preliminary orbit, separating from the third stage of the Soyuz booster as planned. But at that point, a telemetry issue cropped up, and there was no data being received in the Russian Mission Control Center in Korolyov outside Moscow that confirmed the deployment of navigational antennas or the repressurization of the manifold system in the propulsion system of the Progress cargo vehicle. There was confirmation received of the deployment of solar arrays to provide electrical power for the Progress, but not confirmation of the deployment of those navigational antennas that are needed to guide the Progress in for its automated rendezvous and docking to the International Space Station. As a result, a few minutes later, the Russian flight controllers determined that they would not be able to pursue a fast-track 4-orbit 6-hour rendezvous with the International Space Station as planned today, deferring to a backup 34-orbit 2-day rendezvous plan, which is carried as a backup capability on all unpiloted Progress and manned Soyuz spacecraft that are launched to the International Space Station. So with no rendezvous capability in play for today, over the last 2 orbits over Russian ground stations, additional efforts were made by the Russian flight control team to send commands through the telemetry system on the Progress vehicle so that data could be received on the ground. But an hour and a half ago, and again within the hour, there was no joy in receiving telemetry on either of those 2 passes. The next opportunity to pass over Russian ground stations on what is called Daily Orbit 3 for the Russian flight control team is about 55 minutes from now at about 6:44 a.m. Central Time, 7:44 a.m. Eastern Time. So we'll sign off for the moment as we continue to try to establish a stream of telemetry from Progress 59 and for the Russian flight control team to establish a communications link with the spacecraft. We will resume our Progress 59 coverage this morning at 6:30 Central Time, 7:30 Eastern Time, just ahead of the next ground station pass for Progress over Russian ground stations. Until then, we'll be back on the air within the next 40 minutes at the bottom of the hour at 6:30 Central Time. This is Mission Control Houston.
Hi, I'm Neil deGrasse Tyson, and you're watching NASA TV. Is it finally in HD? Did they finally do that?
desktop, laptop, bus stop. Catch This Week at NASA on the go at www.nasa.gov/TWAN or at home on NASA television. This Week at NASA, NASA's highlights of the week from Earth and beyond.
Hubble, the telescope that was supposed to unlock some of the biggest mysteries of the universe. Well, it did all that, and then some.
Hubble, more than any of the others, had so much capability in its basic design that it allowed scientists to answer those questions, but in the process, many more questions popped up.
Hubble's greatness was not so much perhaps in discovering entirely new things, but in taking all kinds of hints and suggestions that we've had before on a variety of phenomena and turning those into actual facts.
For example, we've known for a long time the universe is expanding in all directions.
The big question at the time was, how much is the universe slowing down? And the reason that was such an exciting question was because that would tell you how much stuff there was in the universe that would gravitationally attract and slow the expansion.
But asking that question led to one of the biggest surprises of the 20th century. Our universe is expanding at an ever faster rate, under the push of what's been called dark energy.
Dark energy is this pretty mysterious component of the universe. It makes up about 70% of the mass energy budget of the universe, and its strange aspect is it appears to have a kind of repulsive gravity, which is causing the universe to expand faster and faster.
It's actually speeding up, and that's bizarre. That's nothing that we'd expected, and apparently there's a new entity in the story that we had not taken into account.
It's not often that you discover most of the universe. That can only happen once.
And that discovery led to worldwide acclaim in 2011.
Professor Saul Perlmutter, Professor Brian Schmidt, Professor Adam Rees. You have been awarded the Nobel Prize in Physics for the discovery of the accelerating expansion of the universe.
I couldn't imagine a more fun scientific measurement to make than something that would tell you if the universe was infinite and tell you if there was an end to the universe. It turned out, though, that the answer was even more fun than that.
But dark energy isn't the only elusive mystery of the universe Hubble has tackled.
A supermassive black hole is where the equivalent of several 100,000 or 1 million or 10 million stars, like the sun, have been crammed into a region in space smaller than a pencil point.
What Hubble did is to confirm that, in fact, there really are these supermassive entities, black holes, in the centers of galaxies. And it seems like that the mass of these interior black holes is related to the amount of star mass in that global central region of these galaxies.
It tells us a lot about how galaxies form and how they grow, and what it was that led to the production of life on this tiny little planet in this vast cosmos.
A cosmos filled with potentially countless planets like our Earth, but too far away to ever visit. Hubble has been taking us to them in a way we never dreamed we could.
Hubble has really given us our first look at what a planet's atmosphere looks like outside of our own solar system. What's the composition, for instance? What's in the planet? What is it made out of? So it's really opened the window to that whole universe out there.
The first detection of the atmosphere of an extrasolar planet was made with Hubble by looking at the transmission of light through the atmosphere and detect sodium absorption. If you can detect sodium, you could conceivably detect molecules that were essential to life or indicative of life in the atmosphere of small planets.
It's not that we will actually look through our telescopes and see a crocodile walking there. So when we say that we will detect life, what we mean by that is that the life forms on that particular extrasolar planet have done enough to modify the atmosphere of that planet so that we can detect those biosignatures. signatures that can only be formed by life, then we will start to be convinced that we're seeing the existence of life.
And what else we're seeing is a universe far different than the one we imagined before Hubble. From the Space Telescope Science Institute in Baltimore, Maryland, I'm Mary Estacion.
Hi, I'm Peter Cullen, and you're watching NASA TV.